Good morning, everyone. A delightful welcome to everyone present in this virtual space to celebrate our 2025 8th state level inter-institutional extravaganza, hosted by Physics Forum, Department of Physics, Bharathasan University. Every grandeur has its humble beginning from 2017. This event has evolved from an offline gathering to an online spectacles, and now as an hybrid festive, bringing together the brightest mind across Tamil Nadu. Apeiron is not just an event, it is a legacy in the making, the legacy that evolves, create, and inspire. Today we come together on this remarkable platform to celebrate excellence, creativity, and passion for science at its finest. With no delay in time, we now get into the inauguration of the event.
I declare the online events of Apeiron 2025 open.
Open hearts, affable welcome. That's how we celebrate our arrival. To commence our event, it's my pleasure to invite Aditya from First MSc Physics to welcome the gathering.
Good morning, everyone. With immense joy and gratitude that I extend a warm welcome to each one of you who joined in this virtual meeting to the opening ceremony of the online events of Apeiron 2025, the 8th state-level inter-institutional physics meet. Apeiron 2025 is not just an event. It is a celebration of curiosity, innovation, and scientific exploration. It is a platform where young minds from various institutions come together to engage in thought-provoking activities. It is my honor to welcome the esteemed faculty members. Firstly, my sincere gratitude to Professor R. Ramesh Babu, Head of the Department of Physics, Director of Research, Bharathasan University. Sir, your visionary leadership and unwavering dedication to academic excellence have been a constant source of inspiration for all of us. We welcome you, sir. We are grateful in welcoming Professor K. Jagannathan, Chair, School of Physics, Syndicate Member, and Director of Center for Nanoscience and Technology, Bharathasan University. Your expertise, guidance, and commitment to fostering innovation in physics are truly commendable and deeply appreciated. We welcome you, sir. It is our privilege to welcome Professor M. Sendilvelan, President of Physics Forum, Professor, Department of Nonlinear Dynamics, whose vast knowledge and inspiring words have left a lasting impact on all participants. We welcome you, sir. I would also like to extend my hearty welcome to Professor P. Muruganandam, Department of Physics, Bharathasan University, for the steadfast encouragement and guidance which have contributed immensely to the successful organization of this meet. We welcome you, sir. I sincerely welcome Dr. T. C. Sabrikarisan, Assistant Professor, Department of Physics, Bharathasan University. Your enthusiastic involvement and continuous support have been invaluable in shaping this event. We welcome you, sir. We take absolute pride in welcoming Rashtriya Vigyan Puraskar Vigyan Sri Professor M. Lakshmanan, Professor of Eminence, Department of Nonlinear Dynamics, who makes complex concepts accessible and inspiring curiosity in his students. Apeiron 2025 is nothing short of majesty. We say it because of the support that we get from the participants each and every year. You give us the motivation to get this Apeiron a boundless, exciting inter-institutional physics meet. We are excited to welcome all the research scholars who have rendered their full involvement and the hard work to make this event a celebration. Hard work in the back end is the virtue of the success. I am pleased and excited to welcome our students of the Department of Physics. Once again, we extend the warmest welcome and looking forward to an engaging and enlightening session with all of you.
I cordially invite Professor M. Sendilvelan, President of Physics Forum, Department of Nonlinear Dynamics, to inaugurate the online events of Apeiron 2025.
Sir, unmute பண்ணுங்க sir.
I declare the online events of Apeiron 2025 open.
Sir, your voice is not audible, sir.
Voice is not at sir. I declare the online events of Apeiron 2025 open. Beautiful. Ramesh, are you able to hear my voice?
Yes sir. Sir, no problem.
Okay. Somebody. ரமேஷ் வாய்ஸ் கேக்குது இல்லைங்களா?
Yes sir. Yes sir.
The power of an idea, strength and passion to begins with the auspicious voice to guide us forward. We are honored to welcome our esteemed Professor M. Sendilvelan, President of Physics Forum, Department of Nonlinear Dynamics, to deliver the presidential address.
Good morning, everyone. I stand before you today with a profound sense of honor and excitement as we gather for this 7th Institutional Physics Meet, Apeiron 2025. It is with great pleasure that I welcome you to this exhilarating competition. Today marks the beginning of a journey filled with challenges, triumphs, and the relentless pursuit of excellence for this two-day inter-institutional events. Apeiron is a momentous occasion where minds from various academic backgrounds converge, bound by a shared passion for learning and the gathering of students from different institutions. It is a testament to the power of education to transcend boundaries and unite us in pursuit of common goals. In the spirit of this event, let us embrace diversity as our greatest strength. This competition serves as a platform for us to showcase our skills, push our limits, and inspire one another to reach new heights. Moreover, let us embrace the spirit of sportsmanship and fair play. While victory is undoubtedly sweet, it is the journey of dedication, perseverance, and unwavering commitment to excellence that truly defines us as competitors. Let us compete with integrity, respect for our fellow competitors, and a gracious acceptance of both victory and defeat. All the best wishes to the participants for the events to be conducted today and tomorrow. In closing, I suggest each and every one of you to seize this opportunity to learn and grow to embrace this occasion with joy and happiness. I declare, okay, thank you.
Thank you, sir, for your words. Our past is not lost. It lies in the memory that lights our way forward. Apeiron 2025, an extravaganza celebration of physics, bringing together bright minds from various colleges across Tamil Nadu. Continuing its legacy for the 8th time, the meet upholds high standard with 15 exciting events designed for undergraduates and postgraduate students. Apeiron is not just a competition, it is a boundless platform to test creativity, knowledge, and active participation. Online event includes EduReel, Trickytronics, Memesters, Cryptic Clues, Postycraft, Verse Vortex, Popo Show, Brainy Battles. Offline event includes Candy Click, Fusion Festivity, Play Smart, Fab Faces, Quizzing Cameos, Jungle Run, Dumb Drama. Let's get ready for an electrifying experience.
Gratitude is the fairest blossom that brings from the soul. And today our heart is filled with it. In this incredible juncture of day one Apeiron, it's my privilege to welcome Jani from First MSc Physics to deliver the vote of thanks.
A warm and gracious morning to one and all. It's my pleasure to propose this vote of thanks of all those who made this gathering meaningful. Feeling gratitude and not expressing it is like wrapping a present and not giving it. So let me take this moment to express my deepest appreciation. I would like to sincerely welcome. Thanks to Professor R. Ramesh Babu, Head of the Department of Physics, Director of Research, Bharatidas University, for his invaluable guidance and constant support, which has always been a cornerstone for events like this. I would like to sincerely thank Professor K. Jagannathan, Chair, School of Physics, Syndicate Member, and Director of Center for Nanoscience and Technology, Bharatidas University. A special thanks to Professor M. Sendilvelan, Department of Nonlinear Dynamics, President of Physics Forum, Bharatidas University, for his inspiring inaugural address and for sharing his expertise which has enriched us all. Thank you, sir. I extend my gratitude to Professor P. Muruganandam, Department of Physics, a forerunner who helped us to get forward. Thank you, sir. I extend my thanks to Dr. T.C. Sabrigirisan, Assistant Professor, Department of Physics, Bharatidas University. His active involvement and unwavering support throughout in organizing the event has been an inspiration. We also extend our gratitude Rashtriya Vigyan Puraskar Vigyan Shri Professor M. Lakshmanan, Professor of Eminence of Department of Nonlinear Dynamics, who is on mission to extend physics in all dimensions. To all the participants, your enthusiasm is what made this event a success. We appreciate all your active involvement and looking forward to your participation in the upcoming event and competition. A special thanks to all dignified faculty members, organizing committees, research scholars, and MSc students. Once again, thank you all for being part of Apeiron 2025. Wishing you all a fantastic and intellectually enriching experience ahead. Thank you.
I request all the online participants of Apeiron 2025 to join their corresponding event using the link. Thank you. Again, I request all the online participants of Apeiron 2025 to join in their corresponding event using the link. Thank you. Once again, if you have any queries, please contact the help desk. I request all the online participants of Apeiron 2025 to join the corresponding event using the link. Thank you.
ஸ்டார்ட் ஆனது வந்து டிசம்பர் 28 1895. அது வந்து ஒரு ஆக்ஷனுக்கு வந்து அந்த ஆக்ஷன் ஸ்டார்ட் ஆனது வந்து பாரிஸ்ல இருந்தால் இருக்குது. அது வந்து எப்போ இன்டர்வல் டைம்ல வந்துச்சுன்னா, எப்போ நம்ம ஒரு சினிமா வந்து டிவிக்கு வந்ததோ அது மாதிரி ஒரு இன்டர்வல் டைம் இப்போ வந்து ஒரு எண்டிங் டைம்க்கு வந்திருக்கு. ஏன் எண்டிங் டைம் அந்த மாதிரி சொல்றேன்னா, லவ் வெர்சஸ் சினிமாட்டிக் பிசிக்ஸ். இந்த காலத்துல எல்லாரும் அன்பு காட்டுற மாதிரி, not only we are going to the priority to the parents, we are going to the priority to the cinema also. So my ending is cinema is playing a big role like a love in life. Thank you all.
Thank you. Lot number 12, Luna Compact. Now you can present your poster. Luna Compact. Lot number 12. Are you present?
Hi, sir.
Okay. Okay.
Sir, Luna compared the various concepts of physics, particularly classical mechanics and modern physics. It includes reference to famous scientists like Isaac Newton, depicted under the apple tree, and Albert Einstein with his famous tongue-out expression. Newton's law of motion, depicted with the force, pulleys, inclined planes, and seesaws. Einstein's theory of relativity, E equal to mc square. Gravitational formula, e.g. Newton's law of universal gravitation. Work energy and power equations. Kinetic energy, potential energy. Electromagnetic concept and light bulb atomic symbols, circuit-like representations. Motion and kinetic equations. U equal to ut plus 1 by 2 at square. Velocity formulas. Vectors and the formula. Force. Free body diagram, inclined plane of forces. So this diagram represents that many of physical hello. சார் இந்த டயக்ராம் பொறுத்தளவுக்கு எல்லாமே ஃபிசிக்ஸ் ரிலேட்டடாக தான் வரைஞ்சிருக்கேன். ஏதாவது மூவி ரிலேட்டட் அப்படின்னா
Time's up. Thank you.
Thank you, sir.
Lot number 13, Brightly Star. Now you can present your poster.
Good morning, everyone. Myself, Bharati, representing Brighty Stars from Tyagaraja College. I'm going to present about wormholes, a mind-bending concept that has fascinated physicists and science fiction fans alike. As part of the cinematic physics, we are exploring the intersection of physics and cinema. Today, we are going to dive into the theoretical physics of wormholes and examine how they have been depicted in movies and TV shows. From Interstellar to Star Trek, wormholes have been a staple of science fiction for decades. Let's see the real physics behind these cosmic shortcuts and how we can really use them to travel through space-time. So, what is a wormhole? A wormhole is a hypothetical shortcut through space-time connecting two distant points. It's like a tunnel or a tube that allows matter and energy to travel through it, potentially allowing for faster than light travel. And there are certain types of wormhole. Traversable wormhole, a stable tunnel-like structure that connects 2 points in space-time. Non-traversable wormhole, which is not stable and cannot be traveled through it. Quantum wormhole, a theoretical wormhole that exists at the quantum level. And wormhole is segmented by mouth, throat, and other mouth, and ergosphere. And there are some movies that feature wormholes like Interstellar. A team of astronauts travel through a wormhole in search of a new home for humanity. And Star Trek and Guardians of the Galaxy, etc. like that. Finally, thank you for everyone who took time to visit my poster presentation and engage in discussion about wormholes and cinematic physics. Thank you. Thank you again.
Thank you. Lot number 14, Igro White Rings. Now you can present your poster.
Good morning, everyone. I'm Darshini from Tyagaraja College. It is my privilege to discuss how physics helped in cinema's growth. We know that projectors are the primary tool that brings cinema to the masses. So I envision the evolution of projectors from natural projection used by cavemen to modern projection developed over recent decades, which is placed in spiral at the center that represent the projector lens. Next, I placed power and focal length formula, which provide high quality camera lens. Next, the film camera symbolized the origin of cinema. As we all know, silence is darkness and sound is the spark that brings cinema to life. Here, the physics concept of acoustics plays a crucial role, enabling cinema to engage audience worldwide. Next, CMOS. CMOS technology enable efficient high-speed image capturing, leveraging paired transistor to amplify and process light signals. Next, quantum dots in right down corner, which revolutionized cinema displays with nanocrystal technology, emitting precise wavelength of light to enhance brightness. Next is CGI, which have captivated today cinema world, tricks the brain with binocular disparity. The physics involved is gyroscopic motion. Next, astronauts that represent cosmic setting used in cinema. Last but not least, spectrum plays a pivotal role in creating immersive visual, evoking emotion and setting the tone for storytelling through light and color manipulation. In conclusion, my poster showcase how physics brings cinema to life, from light and sound to motion and special effects. Filmmaking isn't just an art, it's a science deeply rooted in optics, acoustics, motion, and perception. Thank you for this great opportunity.
Thank you. Lot number 15, Cosmic Creatures. Now you can present your poster.
Good morning to everyone. First of all, I will explain the theory of relativity. If the object moving at a constant speed, especially near the speed of light, the law of physics are the same for all observer recorders of the motion, and that the speed of light is constant. Time dilation, time slows down at high speed. Length constitution object appear shorter when moving fast. Gravity not as a force, but as a curvature of the space and time caused by mass and energy, space and time around them, and the bending wheel gravity. Quantum physics is a branch of science, the particle at the smallest scale, like atom and subatomic particles. Its energy and matter become both like particle and waves. For example, quantum physics uses the cinema like Interstellar, using time travel and parallel universe and superposition. Then, post-Einstein considered is a unique state of matter that forms when a group of bosons are cooled to temperature very close to absolute 0 Kelvin. For example, extremely low temperature the particle low almost all the energy and mass into single quantum state as one superparticle with the same energy. Then, pendulum is a object subsent from the fixed point at serving back and forth under the force of gravity. It consists of weight attached to the string or rod. Motion is called oscillation. The overall concept I used in the poster was Albert Einstein's invention and physics later motion and laws to create the cinematic physics. Thank you.
Thank you. Lot number 16, Burning Sense. Now you can present your poster.
Cordial greetings to everyone. The poster I have designed based on bringing physics to life through the power of cinema is based on Interstellar. Interstellar is one of the finest examples of how science can be beautifully integrated into cinema. The movie explores complex concepts like black hole, wormhole, and time dilation, not just as a plot device but as accurate representation of actual physics. One of the most striking scientific ideas in the film is gravitational time dilation, shown when the crew lands on Miller Planet. Due to its proximity to a massive black hole, time moves much slower than, 1 hour equals to 7 years on Earth. This isn't just science fiction, it's based on Einstein's theory of general relativity. What makes it truly exceptional is how it visualizes abstract concepts like higher dimensions and the nature of time in a way that's both scientifically grounded and emotionally powerful. So I conclude by saying that it is a synergy of science and art that shows that even the most advanced theories can be both understood and felt. Thank you.
Thank you. Lot number 17, Post Fusion. Now you can present your poster.
Hello everybody, my name is Sen Mohammad Yusuf from G10 Arts College. Today I'm going to present about
cinematic physics, physics in the form of cinema. If we see about cinema is nothing about physics. We think cinema and physics are not interrelated to anyone, but without physics there is not even cinema. Now in my poster you can see in the left side about our Interstellar, where we can, it explains about the Einstein relativity. And if we talk about Ant-Man, where he can swing, is full of quantum physics, in which he used the pin particles to shrink himself. If we go after the Iron Man suit, is full of material science. In its chest, he have a reactor, which is a full infinite energy where he get from bombarding of a 2 hydrogen atom. If we come about Spider-Man, he swings without physics. Spider-Man cannot involve, because in the string what the tension he want to put and what is the mass of the body and in what angle he want to swing with help of web. And if we talk about the car at the top, it's full of thermodynamics, where we can talk about efficiency of engine. If the efficiency is good, we can get a good engine where we can go into the high speed. In Star Wars, we can see about the lightsaber.
Lot number 17, we cannot hear you. Okay, time's up anyway. Thank you.
Thank you. Lot number 80, Electric Eagles. Now you can present your poster.
குட் மார்னிங் சார். ஒரு படம் அழகா அமைய முக்கியமானதே லைட்டிங். சினிமால லைட் இல்லாம எதுவுமே இல்லை. அப்படிப்பட்ட லைட்டிங் இருக்கிற பிசிக்ஸ் அதிகம். அதனாலதான் நான் பிசிக்ஸ் ஆஃப் ஃபிலிம் லைட் என்ற கான்செப்ட் எடுத்திருக்கேன். ஃபர்ஸ்ட் ஒன் ஆஃப் த மெயின் கான்செப்ட் இட் எலக்ட்ரோமேக்னெட்டிக் ஸ்பெக்ட்ரம் ஆஃப் லைட். ஒரு படம் நம்ம பார்க்கும்படி அமைகிறதுக்கு முக்கிய காரணமே ஸ்பெக்ட்ரம் லைட். த ஹோல் ஸ்பெக்ட்ரம் இஸ் டிவைடட் இன் வேவ் லென்த். அதுல ஒரு சின்ன பார்ட் ஆஃப் ஸ்பெக்ட்ரம் தான் விசிபிள் டு ஹியூமன் ஐவ். டெம்பரேச்சர் இன் கெல்வின். The film lighting main concept color temperature. ஃபிலிம்ல வண்ணங்களை கொண்டு வர இதை பயன்படுத்தலாம். நமக்கு மூவில கேண்டில் லைட் போட்டோ வேணும்னா நம்ம லைட்டை 1000 கெல்வின்ல வச்சு எடுக்கணும். அதுலயே நம்மளுக்கு இப்போ சன்லைட் வேணாம் அப்படின்னா கெல்வினை கம்மி பண்ண நம்மளுக்கு ப்ளூ லைட் வரும். நம்ம கேமரால ஃபில்டரை யூஸ் பண்ணுவோம். வெரி இம்பார்ட்டன்ட் பிசிக்ஸ் லா வந்து ரிலேட்டட் டு லைட்டிங். இன்வெர்ஸ் ஸ்கொயர் லாவ். ஒரு லைட்டிங்க சும்மா வச்சிட முடியாது. அதுலயும் ஒரு பிசிக்ஸ் இருக்கு. குறிப்பிட்ட 3 பெயிண்டிங்ல வச்சாதான் நமக்கு லைட்டிங் பெர்ஃபெக்டா வரும். கீ லைட், ஃபில் லைட், பேக் லைட். கீ லைட்டு நமக்கு அதிக ஒளியை கொடுக்கும். ஃபில் லைட்டு நமக்கு ஒளியின் அளவை அதிகரிக்கும். சாதாரண போட்டோல பிசிக்ஸ் இல்லாம இல்ல. லைக் எலக்ட்ரோமேக்னெட்டிக் ஸ்பெக்ட்ரம், ஸ்கேட்டரிங், ரிஃப்ளெக்ஷன், அப்சார்ப்ஷன். ஒரு போட்டோவுக்கு இவ்வளவு பிசிக்ஸ் இருக்கு. அதுல மல்டிபிள் போட்டோ வைக்கிறது தான் மூவி. அப்போ பிசிக்ஸ் இல்லாம சினிமா இல்ல. தேங்க்யூ சார்.
Okay, thank you. Lot number 19, lightning lasers. Now you can present your poster.
So a warm greeting to all. This is Devashri from Lightning Lasers team. So from my point of view, the most interconnected thing in cinematic physics is camera. This poster mainly implies the advancement of camera over the period. The significant area where the development occurs are sensors, image processing, and the size and design of the cameras and the user's experience. So in old models, the resolution was limited by the size and the type of the film which is used in the camera. Developing film requires a chemical process in the old edition of the camera, and also the size of the old model is often bulkier and heavier, especially in the films like SLRs. The uses of the old cameras requires a more in-depth understanding of the photographic principles like aperture, shutter speed, etc. But in the modern one, the digital sensors like CCD or CMOS is used, which gives better image quality and also handle low lighting conditions. It also equipped with real-time adjustments like noise reductions and also provided with the Bluetooth and Wi-Fi, which gives a connectivity and sharing between the other devices. It has a simple and smart features which is more accessible for the beginners, and also the modern one is handy. And my conclusion is that The transition from old to new camera models represents a significant evolution in technology, functionality, and users' experience. These advancements makes photography more accessible and versatile, catering to both professional and hobbyistic alike. Thank you to all.
Okay, thank you. So I have an instruction. If participants have any questions, you can write it in the chat box. Thank you.
Part number 20, connected. Now your poster.
Good morning, one and all present here. I am here with an interesting topic, namely, sir, I'm audible.
Yes, you are. You can go ahead.
Okay, sir. Cinema plays a major role in developing the physics and boosting the innovations, makes curiosity to youngsters. So let me classify into two. They are direct and indirect. Here, first, let me explain about indirect. If I ask who is your favorite actor, all may say as Vijay. So we know the diving skill of Vijay in Sura movie. It's because he holds his fingers and hands. It's all because of angular momentum. We know Rajarani movie, Pichaikaran, etc. That we saw a hospital scene. There they show stethoscope, endoscopy, etc. The basic principle for those are physics. These are the indirect type of concepts in physics. So let me explain about the direct. It's all about science fiction movies, and a series of movies which are purely based on this physics concept is Indran 2.0, Black, Tick Tick Tick, etc. In the Indran movie, it's a robot's life. The producer adds their delusion to the movie to make it better, and the robots which have emotions like that. So in Tick Tick Tick, we previously know about Kalpana Chawla's death incident, and many concepts and knowledge are shared here. The movie is full of science fiction movie, and an asteroid which may hit the Earth in 7 months, and it threatens the whole people in Chennai is the major theme present here. So we know about the dark. Thank you, sir.
Thank you. Plot number 21, Nuclear Nights. You can present your poster.
Good morning, sir. Thank you for giving me this opportunity. I am Chandru from team of Nuclear Nights. Physics and involved in the cinematic and cinematic in movies. Technology, projector, sound, physics of screen materials, speed of sound. Screen technology. The material of the movie screen affects how much light it reflects. Projectors are popular because they are efficient, long-lasting, and can be produced in a wide range of colors. Sound. The placement of configuration of speakers affects the sound of quality in a movie theater. Speed of sound. Sound in a approximately 2 at temperature. Physics of screen materials, reflectance to reflect the light. Different materials have Thank you.
Okay, thank you. Plot number 22, Quantum Plata. You can present your poster.
Good morning, sir. I am Srija from the team of Quantum Planters. Cinematic physics project visually connects movies and physics, specifically optics, brightly colored it features film reels, a camera, lenses, and a theater stage highlighting light role in filmmaking. AI suggesting exploring artificial intelligence impact on cinema. The image demonstrates a basic understanding of how physics understand movie technology. Thank you, sir.
Okay, thank you. Lot number 23. Change task. Now you can present your poster.
Good morning all, this is C. Divakar. My poster is based on the concept of Inception movie, which is directed by Christopher Nolan. Inception movie is based on the key themes of dream within a dream world and time dilation. Like time moves slower in the deeper dream levels, but in reality, it feels like just minutes. Dream world doesn't obey the laws of physics because they decepted by humans or walking on the wall. Concept of kick in my poster is used to wake someone from the dream. This is how physics is related with the Inception movie. Thank you.
Thank you. Lot number 24, Triangulum Galaxy. Now you can.
Good morning to all. This is Muhammad Ismail from Alua College. I created a poster based on general relativity theory in Interstellar movie. Interstellar used general relativity key in ways. First of all, gravitational time dilation. Time moves slow near strong gravity on Miller's planet. 1 hour is equal to 7 years on Earth due to its proximity to the black hole Gargantua. Second of all, black hole visualization. Gargantua's appearance is based on real physics force and accretion disk and gravitational lensing. Third is time as a dimension. Cooper interacts with a tesseract in the black hole, visualizing time as a physical space inspiring relativity higher dimension. And the last is wormhole, a shortcut through space-time aligned with the Einstein field equation. Physics, if thrown, ensured scientific accuracy in these concepts. Thank you, sir.
Okay, thank you. Lot number 25, Mars Eagle. You can present your poster.
Good morning to everyone. My team name is Mars Eagles from Valur College of Science and Management, Karur. My post based on Newton's second law. Newton's second law of motion describes the relationship between a body, mass, the net force acting on it, and its acceleration. It is commonly expressed by the equation F is equal to m into a, where F represents the net force acting on the object measured in newtons. M represents the mass of object measured in kilograms. That represents the acceleration of the object measured in meters per second squared. In similar terms, Newton's second law states that the acceleration of an object is directly proportional to the net force acting on it. This means that if you double the force, you double the acceleration. Pushing a grocery cart. The harder you push, greater force. The faster the bus accelerated, a heavier bus, greater mass, requires more force to achieve the same acceleration. Kicking a smaller ball. Example, the stronger kick, greater force, will cause the ball to acceleration more. A bus accelerating. The bus engine provides the force that causes it to accelerate. A more powerful engine, greater force, will result in greater acceleration. Thank you.
Thank you. Lot number 26, Newton Riggs. Now you can present your poster.
Good morning to all. I am very excited to speak about the topic cinematic physics. I prepared my post based on the concept of black hole in Interstellar movie, directed by Christopher Nolan. Interstellar movie is grounded in real science, particularly relativity and black holes. In this movie, near the end, Cooper enters a tesseract representing a five-dimensional space created by advanced beings. The black hole Gargantua is designed with real physics. Unlike movie black holes, Gargantua has an an accretion disk that bends light around it. The stronger the gravitational pull, the slower time moves for an observer near it compared to someone farther away. Is the time dilation that is general relativity is used in this movie Interstellar. Thank you, everyone.
Thank you. Slot number 27, black holes. You can present your poster.
Good morning to all. I'm myself Jamnanidhi. This poster represents Newton's law of motion. The images, first image represents Newton's first law of inertia, which states that an object at rest stays at rest, and an object in motion stays in motion. The above image, Walker maintains balance by adjusting their center of mass, demonstrating inertia in motion. The second image tells about martial arts kick. This represents Newton's second law, F equal to ma. F represents force, m represents mass, and a represents acceleration. That's called F equal to ma. The third image this third image represents action and reaction of third law. Every action has an equal and opposite reaction. This creatively connects physical concept to real world examples from movies, making Newton's laws of motion visually engaging. Thank you to all.
Thank you. Slot number 28, Titan square. Now you can present your poster.
Good morning, sir. Myself, Praveen. This image is a combination of artists and scientific element related to space and gravity. Let's analyze it from the physics perspective. Gravity and microgravity, the text is gravity, which is protest astronauts in the facing extreme challenges due to the absence of gravity. In space, objects experience free for all around Earth, creating the sensation of weightless. This is why astronauts float inside the space gravity. This image mentions that microgravity leads to muscle and bone loss, dysfunction, and long-term health issues. This happens because in space the human body does not experience the constant resistance and pressure it does not have due to the gravity over time. Muscles and bones weaken as are not being used in the same way. Gravity forces in spaces the text also mentions black holes and high-speed impacts. In black hole, gravity is so strong that not even light can escape. Thank you, sir.
Sir. Thank you. Slot number 29. For me, find it. Now you can present your poster.
Good morning, everyone. I'm Nestor lot number 29 of Team Fermi Fenders, and the topic of cinematic physics. I compared this topic with that. This is mechanics and movements of dance. I'm so interested in that, so I choose this type of theme. First, I choose the gravity pull because dancers move in slow motion as if pulled by an invisible force, exploring the concept of gravity. And next is friction. Dancers use floor walks and body isolations, demonstrate the power of friction, incorporating props like block or wheels and lost in momentum. A high energy dance piece of showcasing the concept of momentum with the dancers building speed and energy throughout the performance. So they are all based on the mechanics. I compared my topic in my dance. This is the explanation of my topic. You can ask me, sir, why you choose this topic. In this, I explained the whole performance of dance, and in this physics theme, I compared these three styles of dance in the name of gravity pull, momentum, friction. We can choose many topics, but these three topics explain the whole dance performance in mechanics concept like a Lakshmi movie and anybody can dance, etc. Thank you, sir. Am I audible to you, sir?
Audible. Okay, thank you.
Okay, sir.
Lot number 30, Go on and start. Now you can present your poster.
Good morning, sir, and my dear friends. I will discuss about the three cinematic movies, Interstellar, Martin, and Passenger. First of all, Interstellar is a scientific மூவி. அதாவது நம்ம எப்படின்னா நம்ம வந்து எப்பவுமே நம்ம சர்ஸ் அண்ட் ஸ்டாஃப்ஸ் நடத்துற எந்த லெசனையுமே வந்து லெசனா நடத்துறப்ப நம்ம வந்து கவனிக்க மாட்டோம். இதுவே ஒரு மூவி அப்படி இல்லைன்னா லைவா அப்படி இல்லைன்னா எக்ஸ்பெரிமெண்டா பண்றப்ப நம்மளுக்கு வந்து புரிஞ்சுக்கிறதுக்கு கொஞ்சம் ஈஸியா இருக்கும். அந்த மாதிரி சயின்ஸ் மூவிஸ் தான் இருக்கிறது இன்ட்ரெஸ்டெல்லாம். ஃபர்ஸ்ட் ஆஃப் ஆல் அது எப்படின்னா கிரையோஸ்லீப்ங்கிறது என்னன்னா நம்ம ஒரு மனுஷன் ஸ்பேஸ்க்கு போறதுக்காக பூமியிலேருந்து ஸ்பேஸ்க்கு போறப்ப அதே ஏஜ் அண்ட் அந்த ஃபுட்ஸ் எந்த ஒரு இதுவுமே இல்லாம கிரையோஸ்லீப்ல மூலியமா போக முடியும். ஏன்னா இங்கேருந்து நம்ம வேற ஒரு ஸ்பேஸ்க்கு அப்படி இல்லைன்னா பிளானெட்டுக்கு போகிறப்ப டைம் டிராவல் ரொம்ப ஆகும். அதோட இன்டர்ஸ்டெல்லார் இருக்குல்ல அந்த பிளாக் ஹோல், வார்ம் ஹோல் அண்ட் வந்து டைம் டிராவல், அதுக்கப்புறமேட்டா பூமியில இருக்கிறது வந்து 3 டைமென்ஷன், 4 டைமென்ஷன் 5th டைமென்ஷனுக்கு பாசிபிளா இருக்கிற மாதிரியும் இன்டர்ஸ்டெல்லார்ல நம்ம கிறிஸ்டோபர் நோலன் சொல்லியிருப்பாங்க. நெக்ஸ்ட் என்னன்னா இந்த கிராபிக்ஸ் மூலியமா சிஜிஐ விஎஃப்எக்ஸ்ங்கிற கிராபிக்ஸ் மூலியமா எப்பவுமே ஸ்பேஸ்ல போய் ரியாலிட்டியா எடுக்க முடியாதுல்ல, அதனால சிஜி அண்ட் விஎஃப்எக்ஸ் கிராபிக்ஸ் மூலியமா நம்மளுடைய டைரக்டர்ஸ் வந்து ப்ரொடியூஸ் பண்ணிருப்பாங்க. தென் வந்து மார்டின்ல வந்து மாஸ் வந்து அங்க போய் மாட்டிக்கிறதும், அந்த மாஸ் மாட்டிக்கிறப்ப எந்த ஒரு பயப்படவும் இல்லாம எப்படி வந்து நம்ம எப்படி அந்த இடத்துல வந்து இருந்து 4 வருஷத்துக்கு இது பண்ண முடியும் அப்படிங்கறத மார்டின் சொல்லுவாரு. பேசஞ்சர்ஸ்ல வந்து லைக் வந்து போகும்போது இந்த மாதிரி அவங்க வந்து அந்த சில ஆக்சிடென்ட்ஸ் நடக்கும்ல, ஸ்பேஸ்க்கு டிராவல் பண்றப்ப ஆக்சிடென்ட்ஸ் அந்த என்ன நடக்கிறத நம்ம எப்படி வந்து சால்வ் பண்றதுங்கிற மூலியமா நிறைய சொல்லியிருப்பாங்க. தேங்க்யூ சார், டியர் ஃப்ரெண்ட்ஸ்.
Thank you. Plot number 31, Oscillation Outlaws. Now we can present your posters.
Yes, present. ஸோ நான் எடுத்திருக்க டாபிக் வந்து சினிமாட்டிக் பிசிக்ஸ் அப்படின்னு ஒன்று எனக்கு என்ன தோணுச்சுன்னா, எல்லாருமே மோஸ்டா ஃபாரின் ஃபிலிம்ஸ் பற்றி தான் பேசுவாங்க. பட் ஆனால் இந்தியன் ஃபிலிம்ஸில் மோஸ்ட்டாக பிசிக்ஸ் இருக்குமான்னு கேட்டால் பிசிக்ஸ் இருக்காது. மோஸ்ட்டாக பிசிக்ஸை கொலை பண்ணியிருப்பாங்க. பட் ஆனால் ஒரு சில பாயிண்டோ இல்லை ட்விஸ்ட்லேயும் முக்கியமாக சேர்த்துருப்பாங்க. ஸோ நான் அதையும் முக்கியமாக சில ஃபாரின் ஃபிலிம்ஸையும் மட்டும் இன்க்ளூட் பண்ணலாம் அப்படின்னு இன்க்ளூட் பண்ணியிருக்கேன். ஸோ என்னன்னா ஃபர்ஸ்ட் வந்து இன்டர்ஸ்டெல்லாரை நம்ம ஸ்கிப் பண்ணவே முடியாது. பிசிக்ஸ் இல்லாதுன்னு சொல்லவே முடியாது, ஏன்னா அதில் பிசிக்ஸ் இருக்கும். ஸோ அதை பற்றி நிறைய பேர் எக்ஸ்பிளைன் பண்ணிட்டாங்க. ஸோ நான் அதை லீவ் பண்ணிடுறேன். ஸோ ஸ்பேஸ் ஆடிசி 2001 அப்படின்னு சொல்லிட்டு ஒரு மூவி, ஃபாரின் மூவி தான். அதுல ஆர்டிஃபிஷியல் கிராவிட்டி சென்ட்ரிஃபியூகல் ஃபோர்ஸ் வச்சு மேக் பண்ணலாம் அப்படின்னும் அந்த டெக்னாலஜியை 1968லயும் யூஸ் பண்ணியிருந்தாங்க. அதோட அடுத்து இப்ப நம்மளோட இந்தியன் ஃபிலிம்ஸ்க்கு வந்தோம் அப்படின்னா, நண்பன் மூவில எலக்ட்ரிசிட்டி கண்டக்டன்ஸ் வந்து சால்ட் வாட்டர்ல அதிகமா இருக்கு அப்படின்னு சொல்லியிருக்காங்க. ஸோ அதே மாதிரி பேராண்மைன்னு ஒரு படம், அந்த படத்துல கிளைமேக்ஸ்ல ப்ரொஜெக்டைல் மோஷன் வச்சு அவங்க வந்து மிசைலை டெஸ்ட்ராய் பண்ணுவாங்க. அடுத்து புஷ்பா, இப்போ ரீசெண்டா வந்து புஷ்பா 1 மூவில உட்டோட பயோஎன்ஸ் ப்ராப்பர்ட்டியை வச்சு ஸ்மகிள் பண்ணுவாரு வுட்டை. அதோட சதுரங்க வேட்டையில மேக்னெட்டிக் ப்ராப்பர்ட்டியை வச்சு ரைஸ் புல்லிங், ஆயில் புல்லிங் அப்படின்னு ஸ்கேம் பண்ணுவாங்க. அதோட முக்கியமா இது பிளாக்ன்ற ஒரு படம், அதை நம்ம குறிப்பிட்டு சொல்லியே ஆகணும். ஏன்னா இது மாதிரியான பிசிக்ஸ் கான்செப்ட் உள்ள படம் நிறைய கோலிவுட்ல கண்டிப்பா வந்தாகணும். ஏன்னா குவாண்டம் என்டாங்கிள்மெண்ட்னா என்ன, வார்ம் ஹோல்னா என்ன அப்படின்றத கட் அண்ட் கிளியரா ஒரு 1.5 hours மூவிஸ்ல தெளிவா சொல்லியிருப்பாங்க. ஸோ அது மாதிரி நிறைய மூவிஸ் வந்தாகணும். குறிப்பிட்டு இன்னொரு மூவினா அது துப்பறிவாளன்ல ஒரு குறிப்பிட்ட சீன்ல லைட் வந்து டிராவல்ஸ் வந்து நேச்சுரல் படி என்னன்னா லைட் தான் ஃபாஸ்டா டிராவல் பண்ணும் சவுண்டை விட. ஏன்னா ஸ்பீட் ஆஃப் லைட் இஸ் கிரேட்டர் தென் ஸ்பீட் ஆஃப் சவுண்ட். பட் ஆனா ஆர்டிபிஷியலா கிரியேட் பண்ணி ஒரு மர்டர் பண்ணிருப்பாங்க. அதை கரெக்டா ஒரு பெரிய ட்விஸ்டா வச்சு சவுண்ட் முதல்ல வந்துச்சு, அப்புறம் தான் லைட் வந்துச்சு அப்படின்றத க்ளூவா எடுத்துக்கிட்டு அது கண்டுபிடிப்பாங்க. ஸோ அது மாதிரியான ஒரு நிறைய இடத்துல வந்து சின்ன சின்ன பிசிக்ஸை வந்து இம்ப்ளிமெண்ட் பண்ணியிருப்பாங்க. ஸோ இது மாதிரியான நிறைய மூவிஸ் நம்ம கண்டிப்பா வரணும். தேங்க்யூ.
Lot number 3, Sun Dragons. Now you can present your poster.
Hello everyone, I am Saifuddin. On the wonderful morning of this day, I am very happy to participate in this competition. Let me explain about cinematic physics. Physics-based simulations create realistic animation and visual effect in CGI. Real-world phenomena application. Physics engine replicate real-world phenomena like gravity, friction, and collisions. Authentic animation. Physics-based simulations create authentic animation that mimic real-world behaviors. Realism and accuracy. Physics-based lighting models, materials, and structures ensure realism and accuracy in CGI. Visual effect. Physics-based simulation enable realistic visual effect like explosion, water simulation, hair and cloth simulations. Scientific accuracy. Scientific consulting and R&D ensure accuracy in realism in physics-based simulations. Industry impact. Physics-based in CGI has revolutionized the film and gaming industry. Realistic lighting. Physics-based lighting models simulate real-world light interactions. Thank for me giving the great opportunity. Thank you.
Thank you. Lot number 9, energetic forms. Are you present? Are you present? Okay. Thank you for all the participants. As we come to the end of this wonderful event, I would like to express our deepest gratitude to our talented participants, our respected judges, event organizers, and everyone who made this event possible. Before winding up, let's celebrate this moment one last time with a huge round of applause for all the amazing talents we have seen today. Thank you.
Okay, message to participants. So thank you for your active participation. The winner will be announced tomorrow. Thank you. You can let the meeting.
Thank you, sir.
First of all, a very good morning to everyone present here. I kindly request the participants to wait for some time till the to turn on your cameras.
முடிச்சிடலாமா? 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 முடிச்சிடலாமா?
On the Gmail and the other should be on the quiz link. Participants, though you people know the rules, we shall repeat the rules once again for game's sake. Only 2 members per team can participate. Each and every team should turn on their camera and must be on throughout the event. We have star questions to give you extra points. If 2 teams are tied, the team with the most answered star questions will be chosen as the winner. I repeat, only 2 members per team can participate. Each and every team should turn on their camera and must be on throughout the event. We have star questions to give you extra points. If 2 teams are tied, the team with the most answered star questions will be chosen as the winner. Start பண்ணு. So, without further ado, let's commence the game. Please take your seats and let the quizzing begin. May the smartest team become the champion. I once again repeat the teammates to enable your camera. If the questions appearing on the screen are not legible and clear, kindly zoom your screen to find the readable one.
மேம் ஒரு டவுட் மேம்.
Yes?
நேம் என்ட்ரி பண்ணாமலே உள்ள போயிடுச்சு மேம் ஆட்டோமேட்டிக்கா.
Your team name?
ஸ்புட்னிக் மேம்.
முடிச்சிடலாமா? 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 முடிச்சிடலாமா?
Okay. Is this over? Excuse me, ma'am. Am I audible? Yes,
Yeah.
sir. You can start. Okay, thank you, ma'am. Okay. This is over. Now, let's see the quick history of the competition of physics. Before the 1950s, scientists like Newton, Euler,
Yeah.
really laid the mathematical foundations of physics. In 1950s to 1980s, saw the rise of supercomputers like FM and NASA simulations. From the 90s to 2010, let's see the quick history of the competition of physics. Excuse me, ma'am. Scientists like Newton, Euler, really laid the mathematical foundations of physics. In 1950s to 1980s, saw the rise of finite elements like FM and NASA simulations. From the 90s to 2010, see the quick history of the competition of physics. Excuse me, ma'am. Scientists like Newton, Euler, really see the
Lot number 13. Are you there? Okay. Now move on to lot number 14. Common killers Vishnu Priya. Now you can proceed your presentation.
Okay, ma'am.
Lot number 13. Are you there? Okay. Now move on to lot number 14. Common killers Vishnu Priya. Now you can proceed your presentation.
Okay, ma'am.
lot number 13. Are you there? Okay. Now move on to lot number 14. Common killers, Vishnu Priya. Now you can proceed your presentation.
Topics using physics. Graphical interface with work Gaussian software cause we purpose built molecules setup and launch calculation monitor analyze and interpreting the results we can able to visualize optimized molecular structure orbital electron density surface atomic charges vibration frequencies of higher Raman spectra. Conclusion: it is used as physicist, chemist, biological, and chemical engineering to form quantum chemical calculation. Thank you.
Thank you. Next, lot number 15, Campton creators, Anusha. Now you can proceed your presentation.
Yes, ma'am. Good afternoon, ma'am. Fusing physics with computation. Computation. A computation is any type of arithmetic or non-arithmetic calculation that is well defined. Some complex problems faster and more accurately. That's where computation comes in. It helps model, simulate, and predict things faster and more accurately. Why to fuse physics with the computations? It helps solve complex real-world problems like weather forecasting and material science. Computation turns equations and improves accuracy. History. Pre-computations era 17th to 19th century, early computing 1930 to 1950 century, rise of simulation 1950 to 1980, breakthroughs 1990 to 2010, and tools and techniques. Programming languages like Python, MATLAB, and C++ programs, ML and machine learning, numerical methods, high performance computations and supercomputers, quantum computing for physics. Future of physics, computational fusions. Quantum computing, like future technology for solving ultra complex programs. Advancement in hardware, collaborative research. In scientists from different fields with collaborate to make new things and new discoveries. The future of physics lies at the interaction of theory and computations. Applications, astrophysics, like black holes and galaxy simulations. Quantum physics and material science. Climate science, predicting weather and climate change. Medicines are improving, like MRI scan and biomechanics. Robotics and AI, controlled automated labs, simulations. Conclusion. Computation physics helps scientists simulate, predict, and discover things. Physics decodes the universe. Computation brings it to life. Thank you. Finished, ma'am.
Thank you. Lot number 16, Connect Tech. Sandhya, you can proceed your presentation.
Ma'am, is my screen visible?
Yes.
Fusing physics with computation. So computational physics is a combination of computer science, physics, and mathematics. So there will be a lot of scientific problems which is used to describe real world example for we can consider any real world problems. So what we are going to do is we are going to develop a numerical method for such problem which is explains the problem, and we are going to create an algorithm and stimulate the physical system. So it can be done by using any C++ languages. So it comes under the category of theoretical physics, but it can act as a bridge between the theoretical and experimental physics. So what is the need of computation in physics? In physics, we'll be dealing with the laws of nature. So nature, we are describing the laws of nature in terms of equation, that is a mathematical quantity. So theoretical and experimental calculations are needed to verify our theory. So we are comparing our theoretical result with the experimental result. So exact solutions cannot be obtained for every models. So there will be some complicated equations which is very difficult to obtain an exact solution. So in such cases, computational physics plays give hands to make that to get an analytical solution. And if there is a too much data to process, we can use computation in physics. So we can also develop these physical terms in and digitalized screen, and we can understand the behavior of the system in the nano resolution. So we can, for example, we can even model an Earth-like structure. That is, in by using computation, we can model an Earth, and we can vary certain parameters and identify what is the result of such effects. And we can even understand very complex phenomena. So if we are developing a new model for such a new theory, then we are not able to confirm the result, right? So we are comparing the experimental and we are obtaining the computational result and comparing both, whether we can also conclude whether the model we have created just explains the real life model. And what are the steps involved in computation is two steps. We have to design a mathematical model for a scientific problem, and we have to solve it by algorithms. So in this presentation, we'll be seeing about
Cynthia?
what are the different. Ma'am,
Time's up. Time's up.
thank you, ma'am.
Thank you. Lot number 17, Planet Shams, Kirtana. Now you proceed your presentation. Lot number 17, Planet Shams, Kirtana. You can proceed your presentation. This is the last call for Kirtana. Are you there? Okay, now we move on to next lot number 18, Quantum Platters, Kasturi. Now you can proceed. You can proceed your presentation.
Yes, ma'am.
Ma'am, start பண்ணுவோம்.
Okay, you will start.
Very good afternoon to one and all gathered here. Myself, Ms. B. Kasturi. I am from Team Quantum Platters. My topic is Machine Learning Fusion Physics with Computation. Machine learning is a discipline of artificial intelligence that allows computer to learn and improve from data without being explicitly programmed. Machine learning algorithms are modeled on and training data to set to create a model. How does it work? The flowchart is explained machine learning how it's worked here. Machine learning, is it possible? Yes, of course. It has been done by eminent scientists John J. Hopfield, Geoffrey Hinton, and they got a Nobel Prize in Physics for their work on artificial neural networks and machine learning. Their work has laid the foundation for modern artificial intelligence technologies. John J. Hopfield works create an associative memory that can store and reconstruct images and other patterns in data. Geoffrey Hinton works, we know that he is a godfather of AI, invented a method that can autonomously find properties in data, such as identifying element in pictures. How their work related to machine learning. Their works enable to computers to minimize functions like memory and learning. Artificial intelligence system used to node connected in a network to send and receiving mail and signals. Types of machine learning. There are 4 types of machine learning available here: supervised machine learning, unsupervised machine learning, semi-supervised machine learning, reinforcement learning. Machine learning applications, healthcare industries, finance sector, retail sector, and so many applications are available here. Fusing physics with computation, the study of scientific problems using computational methods to develop scientific solution to complex system of data. Key aspect of fusion of physics and computation in machine learning: physics-based constraints, future-based engineering with physics, hybrid modeling. Benefits of using physics computations: improved accuracy, better generalization, interpretability. Examples of applications: fluid dynamics, structural machines, mechanics, heat transfers. Challenging in fusion physics and computations: model complexity, data recoupment, choice of physics representations. Their research has had a profound impact on various fields, including physics, material science, and astrophysics. It has enabled machines to learn from large data sets and make predictions or decisions. Thank you.
Thank you. Next, lot number 19, Solar Axe, Bhuvaneshwari. You can proceed your presentation.
Please. Good afternoon, ma'am. Are you clear? Audio clear, ma'am?
Yeah, your audible is clear.
Okay. Good afternoon to all. Myself is Bhuvaneshwari. In introduction to the integration of machine learning and physics, the crossroad of physics and computation, combining computing and physics, help scientists solve complex problems, improve prediction and
Bhuvaneshwari?
Yes, yes, ma'am. Yes,
Can you change your slide orientation? Rotate your phone. Rotate your phone on horizontally. Okay, fine.
Combining computing and physical helps scientists solve complex problems, improve prediction and better understanding natural phenomena through teamwork
Slide
and
is not clearly. Zoom out. Zoom out. Don't zoom in, just zoom out.
மேம் வேற ஐடில இருந்து லாகின் பண்ணிக்கலாம் மேம். மேம்
நோ, இந்த ஐடில இருந்து இது பண்ணுங்க, பிரசன்ட் பண்ணுங்க.
ஓகே மேம், ஜாயின் பண்ணிக்கிறேன்.
டேய் இருக்கியாடாமா? ஹலோ.
இருக்கேன் மேம். ஆமா.
ஒன்னும் போனை ரொட்டேட் பண்ணிட்டு ஃபுல்லா ஜூம் பண்ணிருக்கீங்கம்மா. நீங்க அதை ஃபுல்லா ஷார்ட் பண்ணுங்க, ஜூம் அவுட் பண்ணுங்க. ஹரிசாண்டலாவே இருக்கட்டும் போன், ஜூம் அவுட் பண்ணுங்க. உங்களுக்கு பாதி ஸ்லைட் தான் தெரியுது, ரொம்ப ஜூம் பண்ணா தெரியல. இல்ல போன்லயே ஹரிசாண்டல்னு ஒரு ஆப்ஷன் இருந்தது பாருங்க, அதை சூஸ் பண்ணுங்க. கீழே லெஃப்ட்
ஹரிசாண்டலா தான் மேம் இருக்கு. இப்போ
எனக்கு ஃபுல் ஸ்லைட் தெரியலடா. லாக் அவுட் மீன்ஸ் வெளில போயிட்டு திரும்ப ஜாயின் பண்ணலாம்.
ஓகே மேம்.
பிக்கா
ஏன்டா மேம்? ஹலோ மேம்.
Yeah.
Ma'am, I'm Bhuneshwari ma'am. Interdisciplinary energy. Combining computing and physics helps scientists solve complex problems, improve prediction, and better understanding mutual phenomena through teamwork and advanced research methods. History perspective of computational methods in physics. Computational method in physics even from numerical technique used in the 1960s to high performance computing in the 1980s, enabling advanced modeling in the 20s, saw the neural network merging physics with the machine learning, improving prediction. Today, machine learning plays a key role in the handling large physics data sets. The rise of machine learning transformative tools, data-driven methodologies, algorithm innovation, interdisciplinary collaboration. Importance of interdisciplinary innovation, increasing research capabilities, catalyzing breakthrough discoveries. Machine learning fundamentals. Learning data. Machine learning enables system to improve performance by identifying patterns in data, adapting as more information become available over time. Algorithm categories. Key machine learning algorithms are divided into supervised, unsupervised, and reinforcement learning, each serving distinct purpose in a data analysis and decision making. Data transformation processing. The workflow of machine learning include data collection, processing, model building, evaluation, deployment, and continuous learning to drive actionable insights. Key algorithm in machine learning: supervised learning overview, unsupervised learning overview, reinforcement learning dynamics. Principle of physics relevant to computation. Fundamental rules of physics. The principle of physics, including classical mechanics, thermodynamics, and quantum mechanics, provide essential frameworks for developing computational models, enabling accurate, simultaneous, and prediction across diverse scientists and engineering disciplines. Modeling neutral phenomena with physics, framework of physics law, complex system simultaneous, data-driven intentions. Application and impact integration. The integration of machine learning and physics includes prediction modeling. The integration of machine learning with physics allows for the development of models that only one predict outcome more accurately but also adapt to new data efficiently, improving scientific understanding. Interdisciplinary research opportunities. The fusion create unique opportunities for collaboration between physics and data science. Case studies in climate modeling and material science, machine learning in climate forecasting, advanced MLA algorithm enhance climate prediction. They analyze.
Bhuvneshwari, your time's up.
Okay, ma'am.
Thank you.
Thank you.
Next lot number 20, solar eclipse, Kamali. Now you can proceed your presentation.
Good afternoon, ma'am.
Good afternoon.
Good afternoon. Now the topic is machine learning, fusion, physics with computation. What is machine learning? A branch of artificial intelligence focused on algorithms that improve through experience. Why fusion physics and machine learning? Physics provide a structured understanding of the world, while machine learning enables predictive and computational power. Integration derives advancement in science and engineering. Role of physics in machine learning. Incorporating physics principles into machine learning models improve accuracy and generalization. Physics provide constraints that make machine learning prediction reliable for real world and applications. Example for the machine learning, physics inform neural networks and loss function. Applications of machine learning in physics, high energy physics, particle tracking and event stimulation, quantum physics, predicting quantum state, climate modeling, accurate weather forecasting, astrophysics, black hole detection, and cosmological stimulation. This is the image related to applicational physics. Applications of physics in machine learning. Physics inspire loss functions, guide modeling training. Simulation provides synthetic data for model robustness. Physics awareness network modeling complex phenomena like fluid dynamics. Case study. Predicting fluid dynamics with physics informed deep learning. Reinforcement learning in robotics with physical constraint. Quantum mechanics learning for stimulating molecular structure. Challenges and limitations. Computational complexity limit scalability. Data scarcity in physical system creates training challenges. Balancing physics-based prior with flexibility in machine learning models. Tools and frameworks. TensorFlows and ByteX for developing physics-informed models. Simulators like OpenFOAM and LAMMPS for generating training data. Specialized libraries like DeepMind's AlphaFold for specific applications. Future direction, developing hybrid models that combine physics solvers and machine learning, enabling real-time simulation with physics-informed artificial intelligence. Automated discoveries for machine learning, physics laws and phenomena. Conclusions. Machine learning and physics integration enable groundbreaking insights. Application spans diverse fields for astrophysics to robotics. Future holds immense potential for discovery and innovation. Thank you.
Thank you. Next lot number 21, Sputnik, Rosario, John Paul. You can proceed your presentation.
Hello, ma'am. Do you hear me?
Yeah.
Shall I start, ma'am?
Yes, you can start.
Hello, everyone.
First of all, my profound gratitude to all who are here to listen my presentation. Today, I'm going to explain a part named as Gaussian software. From the given topic, machine learning to fusing physics with the computation. Here, this is a Gauss view. This is the front end of your visual with the two section of screens. One is named as an builder and the other one is named as an viewer. The builder is used for building the structural molecular structure, and the viewer is used for the analyzing the builded structure. Then a common question arose in every individual. How can we build a molecular structure? Let's see. The builder page is contained here with the fragment sector full of periodic elements, and the preview of fragments shown in builder page and the creating bond should show on viewer page. In detail, we should classify the fragment page as biological fragments and R group fragments. This is in biological fragments. Biological fragments are basic structural fragments like benzene ring, etc., are obtained for initial structure and then add up with the R group fragments. R group fragments are radical group fragments, such as AMI optimized functional group of fragments for the formation of molecular structure, and then with the initial setup of basic sets. This is in place to calculate the given molecular structure. We should optimize the given molecular structure. After optimization, the Gaussian output given molecular structure is shown. This is an example for Gaussian output file for water. Gaussian is capable of predicting many properties of the atoms and molecules like water optimization. Then there is a lot of tragical point in the view of water optimization. Here we can see that each part of Gaussian software clearly. This is a single point energy. A keyword is SP, which is means S orbital and P orbital only. No keywords lead to HF/STO/-3GSP. Geometry optimization keyword OPT for configuration evaluate gradient of energy. And final, we can lead to vibrational frequency. Keyword is FREQ. It calculates the vibration of each molecule. Thank you.
Thank you. Next, slot number 22, Thermal Thunder, Alagu Murugan. Now you can proceed your presentation.
Okay, ma'am. Am I audible? Am I audible to everyone?
Yeah, you audible.
Yes, my screen is visible.
Yeah.
Hello, is my screen is visible?
Yeah.
Okay.
Yeah, your screen is visible.
Let me start. Good afternoon. Good afternoon to one present here. I was very inspired by the topic machine learning with physics computation. That's why I've chosen the presentation even. I'm going to give a small description about my entire PPT within 3 minutes. Ma'am, I'm just going to give a description about this. I think there is no need for transition of slides.
Oh, okay, okay.
Okay, let me start. Physics with its capabilities undiscovered many mysteries from space-times to relativity with help of other sciences also. The new merge with AI will splash all the histories. The brain that perceives any biological experience is called physical sciences, the combination of physics and AI. Since the quest for knowledge on both physics and technology is never-ending, this new field will feed the thirst. Traditional methods may be slow, limited for new enhancing perceptions. The concept of machine learning will help in quick shift through a massive data sets. Generally, machine learning produces deeper and accurate predictions. AI, with its advancement computational capabilities, can assist researchers in solutions more efficiently. Physics sectors like quantum technology, statistical mechanics, astronomy, when combined with AI, uncover many insights of this field. Nextly, with the AI-based telescopes may discover the formation of universe from Big Bang theory also. Integration of these two fields will help everyone to complete a tedious, repetitive work and processes. The combo with AI in physics is not just a trend; it's a revolution. AI will unlock new patterns and new realms of the scientific discoveries. The topics I'm going to cover in this entire PPT will be physics, the comparison between physics and AI, history, transforming physics to AI, is the process, real-time applications, physical, philosophical and ethical considerations, challenges, opportunities, and futuristic scope, and finally about the AI scientist. Let me explain the fields in my presentation, if I selected. And thank you everyone for your patient hearing.
Thank you. Next slot number 23.
Thank you everyone.
Thank you. Next slot number 23, Victor Wicklings, Shiana. Now you can proceed your presentation.
Ma'am, am I audible?
Yes, you are audible.
Okay, good afternoon, one and all present here. Now I'm going to give an outline of what is my presentation, and so let's see about what is ML. And it is a branch of artificial intelligence, and it is used to learn patterns from data and make decisions without being explicitly programmed. So we have to if we have to understood ML, we should know what is about explicitly programmed. Let's see about what is explicitly programmed. It means we shouldn't be doing many more codings to explain things, and we have to just give a command, and it follows the command to give the results. So in my presentation, we are going to see about what is machine learning and how it works, and how the things are done here, and why there is a need for physics in why there's a need for ML in physics. So basically, ML is based on computation techniques, and physics is full of formulas and the theories. We should combine this both to give precise and accurate results. So how we fuse computation with physics, and what are the fields we use machine learning in physics. So the most primary field we use machine learning is astrophysics and astronomy, because it can able to handle large number of data, and we have to give an accurate and precise measurements, because we would get a lot of noise and external disturbances and scintillations, many other things, and we just need to calculate the precise value. So there is a need for machine learning, and how the things are done here. And in quantum mechanics and quantum computing, this is also ongoing and most prominent researches going on, and which is in quantum mechanics, we in normal computation we use binary methods, but in quantum mechanics we use qubits to calculate things. So we have to fuse this both qubits and machine learning to produce another kind of branch or something to accurately decide the results. So condensed matter physics and material science. Here we will talk about superconductors and their phase transition, and in other physics domains too, like in plasma physics, nuclear fusion, geophysics, climate science, fluid dynamics, and turbulence. So let's see why the 2024 Nobel Prizes about this John Hopfield and Geoffrey Hinton. And John Hopfield invented a network that uses kind of like brain-like simulations to recreate patterns and saving the things. And Geoffrey Hinton uses Hopfield network, which is an extension of the. Yes, ma'am.
Your turn, sir.
Okay, ma'am.
Thank you. Participants, we will declare the results within a 20 to 25 minutes. So you all just hold the meet The shortlisted candidates for Quantum Platus Kasturi, Alagumurugan from Thermal Thunder, Shyana from Virgo Wicklings. Other candidates may leave. The shortlisted candidates stay in the meet.
Thank you, ma'am.
Good afternoon, everyone. The mediocre teacher tells, the good teacher explains, the superior teacher demonstrates, the great teacher inspires. Our inspiration is Professor M. Senthilvelan sir. Now I invite our beloved Professor M. Senthilvelan sir, President, Physics Forum, Department of Nonlinear Dynamics, Bharathasan University, to judge the advanced round of Coco Show event. Please, sir.
Yeah, I'm ready. Yeah. Who will be the first presenter?
Sir, shall we start?
Yes, yes.
Judges, please note. Now presenting cosmic creatures Kirtiga, lot number 5.
Kirtiga, you can start now.
Yes, sir. Shall I start, sir?
Yes, yes, please.
Good afternoon, sir. I'm so grateful for the opportunity to present once again on this thought-provoking topic of machine learning using physics with computation. So, to begin, let me illustrate the concept of machine learning with a relatable example. When selecting a watermelon, we instinctively look for certain features that I've mentioned here. So, our expectation based on the past experience is that the watermelon with these features will taste good. This intuitive process is, in fact, the fundamental aspect of machine learning. So, machine learning is a field of artificial intelligence that enables computers to learn from data and make decisions without explicit programming. So, it enables machines to think like humans and perform tasks like humans, and also improve their performance over experience. So, this makes it a valuable tool in physics, including. So if not programming, then how machine learning actually works? So first, the data are collected in the form of images, texts, audios, or even sensor readings. And this data is in the raw form, which should be processed for usage. And next is the very important process, that is model selection. There are very famous algorithms like neural networking, decision trees, random forests, support vector machines, and linear regressions. And this is then trained to reduce the error, and also and for evaluation step, it is like the accuracy, precision, and other metrics. And only then the model is developed. Next, how can we use physics and computation together? So the basic physics principles can be merged with computational methods for creating new algorithms and models and applications. So some of the physics-inspired computings are quantum, optical, and thermodynamic. So in quantum, we can use quantum mechanical topics to solve problems in a faster way than the classical computers. And next, how can computation be used in physics? So first is simulation. Here we can perform experiments virtually, and then data analysis is something which is very useful. Like there are lots and lots of data in areas like particle physics, material physics, and astrophysics, where data analysis can be very useful. And then it is a real-time model of climate modeling and environmental sustainability, and these also can be used using computation. And then in energy systems, in biophysics too, and also in optimizations. And next is something that is very special for India. So India's Chandrayaan Mission 3 was a successful landing on Moon South Pole. It is also a AI-powered navigation system. Here, the machine learning algorithms analyze the data from various sensors and cameras, and the decision is made real time. Here, it is the accuracy and efficiency of the AI-powered system for correct navigation. And also, the machine learning topic gained the Nobel Prize for Hopfield and Hilton this year for the foundational discoveries and invention that enabled machine learning with artificial neural networks. These two worked independently. Hopfield created a Hopfield network by having physics concept atomic spin as a basic concept, and Hinton developed a Boltzmann machine which used statistical physics concepts. And next is the images of the artificial and natural neurons. In the first one, we have neurons, and it is replaced in the artificial ones by the nodes. And second is the data which is recreated. The first pattern is the input, and second gives the output. And next is the Boltzmann machine representation. Next, I've given the Hopfield network in terms of energy. Here, the images are given, and then it is moved down the energy level till the correct image is received. So I conclude that we should embrace the existing intersection and transformative advancements. And these are my references. Thank you for the opportunity, sir.
Kirtiya?
Yes, sir.
So what is the connection between your title and the presentation you have given? You have chosen the title as Cosmic Creatures, but you have talked about entirely different topics. You gave an introduction, and I didn't talk much about the topic you have chosen, right? Cosmic Creatures.
Sir, actually, Cosmic Creatures is my team name, sir. That was given by the committee here in BDU. The topic I'm talking about is machine learning fusing physics with computation, sir.
Okay, right. Okay, now I understand. So,
yes, sir. Thank you, sir.
Can you explain what is Boltzmann machine?
Sir, 1 minute, sir. Sir, Boltzmann machine, actually here, I would like to give an example, real-time example, which is very prevalent, sir. Here, we can get the image, someone who is no longer in this world, like they can be brought into life virtually by simply providing AI with the audios, videos, or images. So the machine will create a whole new person, like using the audios or videos, images that we've given, sir. So that is how basically the Boltzmann machine works. So it transfers the signals, and here the recurrent process also occurs. Here the information which is stored already will be studied multiple times, and the output is given, sir.
Okay. Okay. Right.
Yes, sir.
Okay. Who is the next?
Thank you, sir.
Okay. The second one is
Judge. Yeah. Please note the participant going to present is lot number 10, Adira from Force Fusion. Lot number 10, Adira, you can present now.
Good evening, everyone. Is I'm audible?
Yes.
Yes. Thank you, sir. Once again, good evening to everyone. Myself, Adra. I am from the team Force Fusion. Before getting to the topic, I'll give a comparison that.
Athena, can you hide this on the bottom one? Scroll bar. Yeah. Yeah.
Oh, thank you, sir. Thank you, sir. A few years back, a computer program defeated a world chess champion. And today, AI is everywhere. AI can do anything. It can even text message, drive a car, or even diagnose some diseases. So it is possible, right? Let's dive into the field of machine learning. Then what is machine learning? Machine learning is something that which is a subset of artificial intelligence AI. We have to give some data, and according to the data they will give the output may be like making decision predictions, like that. Machine learning can be classified into three types: supervised learning, unsupervised learning, and reinforced learning. Supervised learning is nothing but they will be having a set of data that is already input in it. For a certain input there will be a corresponding output. It can be taken as some examples for that as maybe spam detection, image identification, or some disease diagnosis. And unsupervised learning is nothing but there will not be any labeled data set. The machine should work and give the output. And reinforcement learning, in which an agent will work. Some examples of agent may be AI tool or self-driving cars. Next is the traditional versus machine learning modeling. We all know that in traditional method, we will be using some rules, equations like that. And in machine learning, it is full and fully dependent on data-based. A simple or well-defined problems can be solved using traditional programs, while high and complex unstructured problems can be solved using machine learning. These are some comparison between traditional method and machine learning modeling. I have given some real-world applications of machine learning from social media, transport, financial service, healthcare, e-commerce, virtual assistants. So what are these? These are nothing but that we are using in our daily life. Social media, if we are looking for something in your Google, it will be there in advertisement, in other medias. In transport, the traffic controls will be carried out by the machine learning applications. And in finance, if we if we go to an ATM and pin a wrong pin number, then there will be a fraud detection message to our phones. These all are carried out by the machine learning. Even in healthcare, the diseases like cancers are diagnosed using machine learnings. Uses of machine learning in physics. Coming to our topic, in physics, I have included some of the applications of machine learning in various fields of physics, such as space exploration, material discovery, climate science, fluid dynamics, and nuclear physics. In space exploration, which is a wonderful topic, in space exploration, a large data set can be described by using a machine learning. And next one is rover to collect sample. We are all familiar with the present Chandrayaan-3 rover Pragyan. How interesting to know that how rovers collected samples and detected what material is, what chemical it content, like that. Guiding safe landing. A machine can guide with the image of the surface and how is the terrain or how is the climate, at which distance a spacecraft is there, and it will guide a spacecraft, like giving a smarter brain and eye for the landing of spacecraft. AI assistant for astronauts. Astronauts can communicate with the mission using some gestures or texting message. Global navigators, the current we using in our daily life, GPS, in there also machine learning have a high application. Machine learning in material discovery, in predicting the property of a material before synthesizing. We can give the idea of what materials we are inputting.
Adira?
And yes, ma'am.
Time, sir. Sir, now it's time to questions.
Okay, Akira.
Yes, sir.
Go to the second slide or something. Last we can supervised, unsupervised.
Yes, sir.
Can you? Normally you receive spam in Gmails, right?
Yes, sir. Yes, sir.
Is it comes under a supervised or unsupervised?
It comes under supervised learning, sir.
Are you sure?
Yes, sir. In supervised learning, there
what
will
is
be.
the algorithm being used in that? Do you have idea?
Algorithm used in that will be classifications or some regressions or classifications of
Classification
the
comes under both the supervised and unsupervised, right?
classification means it if we are rawly giving an image or something, it will be classified
Unsupervised.
like yes, supervised.
Unsupervised. Can you go to the last slide, the materials thing?
This one, sir.
Next one.
Materials.
Can you give what kind of algorithm being used? Can you give an example for materials discovery?
Material discovery, if
any one of them.
consider, yes, sir. If
algorithm.
basically machine learning include 5 steps, sir. It will be data collection, data pre-processing.
No. I'm not asking the processing. I'm asking name of the algorithm. Do you know any one of the algorithm being used here? Name of the algorithm.
The algorithm used here will be a comparison, sir. It will be comparing with the.
I'm asking name of the algorithm. Okay, Tira. Okay, good.
Okay.
Yeah, next one, please.
Judge, please note the participant going to present lot number 2, Aishwarya from Luna Combat. Lot number 2, Aishwarya from Luna Combat. Now you can present.
Warm greetings to one and all. It's Aisha from the team Luna Combat is glad to present on the Nobel-winning topic machine learning, fusing physics with computation. Before diving into the context, I have a question for you all. We all know that the ice melts into water at 0 degrees Celsius. But what about zirconium? Zirconium? Does zirconium melts? No. I'm asking about the transition of monoclinic phase to tetragonal phase. Phase transition, zirconium, monoclinic, tetragonal. We are all not familiar with this meta. You are all confused, right? Monoclinic is generally available at room temperature. But what about tetragonal? For its phase transition analysis, here comes our hero, the machine learning. It learns from the data that is already fed and generalizes new data and perform explicit instruction. It is used to analyze data automatically. Here are its types: the supervised and unsupervised and reinforcement learning. Generally, supervised model is trained on labeled data, for example, spam and fraud detection. The unsupervised model is trained on unlabeled data and discovers patterns or structures. For example, anomaly detection in cybersecurity. The last one is the reinforcement learning. This model learns by interacting with an environment and receiving rewards and penalties. For example, including robotics learning to walk. The flowchart here depicts the evolution of machine learning from 1950s to till now. Alan Turing proposed Turing machine in the year 1936 and later the idea of machine learning from the data. Later the same Alan Turing's computing machinery and intelligence introduced the idea of AI and Turing test in the 1990s. The revolution of AI grows in large-scale language models like GPT, BART, etc. The transition from monoclinic to tetragonal happens around 1170 degrees Celsius. Where did we get this data? We get this data by means of machine learning by the process of data collection, feature engineering, machine learning model, training, and finally the data is predictor. John J. Hopeful and Geoffrey Hinton are the Nobel laureates who were jointly awarded in 2024 for their foundational discovery and invention that enable machine learning with artificial neural networks. Generally, the application of ML are in the field of biophysics, condensed matter physics, particle physics, material physics, high energy physics, and astrophysics. Generally, in biophysics, It is used to model biological systems and analyze the complex biomolecular interactions such as protein structure prediction, molecular dynamic simulations, and so on. In astrophysics, it's used to analyze massive data sets from telescope and space missions that include exoplanet detection, galaxy classification, and so on. Generally, ML accelerates data processing in high energy experiments in both high energy physics and particle physics. ML aids in the discovering of new materials and predicting the properties such as magnetic property, defects, are all detected by means of material physics. Already we have seen the one of the example of condensed matter physics, that is the phase transition, in the previous slides. The major advantage of machine learning is that it can automate repetitive tasks, saves time, and reduce human errors. By the same time, its adaptability makes it invaluable for tasks like prediction, pattern recognition, and decision making across various industries. The future of machine learning is that it is moving towards human-like intelligence. Thus, machine learning fusing physics with computation makes our work at ease. Here, I want to mention a thing that neural networks are used in analyzing the phase transition.
Okay.
Hope you enjoyed it. Thank you all for your patient listening. It's Aishu from Lunar Combat signing off. Thank you, sir. I am so grateful for this opportunity.
Aishwarya,
Yes, sir.
what is the difference between machine learning and deep learning?
In machine learning, we used to feed the data into the machines, and then we can get the particular value we need to obtain. But in deep learning, we have to analyze all the records in the past, in the present, and what will be in the future. We have to analyze. But in machine learning, it happens only in a fraction of seconds, sir.
Wrong. Okay, your answer is wrong. Okay. Can you go to the last slide? Last but one. So what is it? What do you mean by ethical concerns?
Generally, ethical concerns, while writing thesis or else something else, we have to follow some of the rules and regulations. Here, the ethical concerns means we are just copying from the source without, that is doing plagiarism, sir.
Okay. Yeah, good. Okay, thanks, Priya. Okay.
Thank you, sir.
Judge, please move. The participant
okay, give me 2 minutes. Give me 2 minutes.
Okay, sir.
Good, yeah. Okay, go ahead.
Judge, please note the participant going to present lot number 18, Kasturi from Quantum Platters.
Yes, ma'am.
Kasturi, you can proceed now.
Yes, ma'am. Very good afternoon to one and all gathered here. Myself, Ms. Kasturi B.
No,
I'm from...
open the slide.
Oh, sorry, sir. His screen is visible, sir?
Yes.
Yes, sir. A very good afternoon to one and all gathered here. Myself, Ms. Kasturi B. I'm from Team Quantum Platters. My topic is Machine Learning, Fusion Physics with Computation. Machine learning is a discipline of artificial intelligence that allows computer to learn and improve from data without being explicitly programmed. How does machine learning works? Machine learning algorithms are modeled on a training data set to create a models. How does it work? The flow chart is explained machine learning how it's worked below. Machine learning, is it possible? Yes, of course. It has been done by eminent scientists John H. Hopfield, Geoffrey Hinton, and they got a Nobel Prize in physics for their work on artificial neural networks and machine learning. Their work has laid the foundation for modern artificial intelligence technologies, for fundamental discoveries and inventions that enable machine learning with artificial neural networks. John J. Hopfield work. In 1982, John Hopfield invented a network that uses a method for saving and recreating patterns. He found inspiration in physics models of how many smart parts in a system affect the system as a whole. The invention became important in, for example, image analysis. Created an associative memory that can store and reconstruct images and other patterns in data. Geoffrey Hinton work. We know that he is a godfather of AI. In 1983 to 1985, Geoffrey Hinton used a tool from statistical physics to create the Boltzmann machine, which can learn to recognize characteristic element in a set of data. The invention becomes significant for example, for classified and creating images. Invented a method that can autonomously find properties in data, such as identifying element in pictures. How their work related to machine learning. Their work enabled computer to mimic function like memory and learning. These inventions are basic of artificial intelligence. AI system used a node connected in a network to send and receiving a signals. Artificial intelligence systems are used in many fields, including medical imaging and climate science. Types of machine learning. There are 4 types of machine learning: supervised machine learning, unsupervised machine learning, semi-supervised machine learning, reinforcement machine learning. Supervised machine learning. A machine learning is the technique that used labeled data to train algorithms to predict outcomes. Unsupervised machine learning is a type of artificial intelligence that uses unlabeled data to find patterns in sites. Semi-supervised machine learning. A machine learning technique that used both labeled and unlabeled data to build models. Reinforcement machine learning is a technique that trains software to make decisions that achieve the best results. Machine learning applications. It's used in many ways: healthcare industries, finance sector, retail sector, social media, image and speech recognition, recommendation systems, fraud detections, healthcare diagnostics, autonomous vehicles. Fusing physics with computations. Physics with computation, the study of science problem with using computation methods to develop the scientific solution to complex of system of data. Key aspect of fusing physics and computation in machine learning: physics-based constraints. By incorporating physical equations and constraints into the loss function of neural networks, the model is forced to learn solutions that the underlying physics of systems. Feature engineering with physics, using derived quantities or features directly based on the physical laws as input to the machine learning model, which can improve the model's ability to capture relevant patterns. Hybrid modeling, combining a physics-based model with a data-driven machine learning model, where the physics model provides initially predictions or guided the learning process, while the machine learning model handles complex data patterns. Benefits of fusing physics and computations: improved accuracy.
Yeah, I think time is over. I think.
Yes, sir.
Yeah, you can go to the. Yeah. Okay. So, can you tell me what is the difference between machine learning and deep learning?
Sir?
What is the difference between machine learning and deep learning?
Machine learning is the artificial intelligence. It's used to execute of program.
Okay. Deep learning.
Deep learning is the
Okay, can you tell me one example where you can use physics-informed neural network?
Quantum physics, sir. Quantum dots, quantum physics.
How? What is quantum dots? Okay. Okay, Kasturi, fine.
Thank you, sir.
Judge, please note the participant going to present lot number 22, Alagu Murugan from Thermal Thunder.
Good afternoon, sir. Can I present now?
Yeah, please. Point.
Night on the
Is my screen visible to everyone?
Only half. Only half.
Okay. Yes. Okay. Now is my screen visible?
No, Alagu Murugan. Only half is visible.
Sir, now I'm presenting my sir.
No.
Don't know how it is looks, sir, but I'm showing the full screen.
Yeah, you go to the next slide. Let's see. Go to the next slide. And now it's fine. Yeah. Okay. Go to the next.
Okay.
Yeah. Go to the next slide. Are you able to move? Are you able to move? You can just go to the next slide.
Yes, sir.
It's not moving, I think.
Sir.
Now it's fine. No. Okay, you go ahead. Yeah.
Okay, sir. We'll start from now. First of all, good morning, good afternoon to everyone. Thank you for giving me this opportunity. Let me start my presentation. The topic machine learning with physics computation. I was very much inspired with this topic. Let me start. First, we start with this. Sorry, I'm going to introduce myself.
No, you have very little time, so just go into the matter.
Okay, sir. Okay, sir. First, I'm going to start with the physics and AI. Physics that is concerned with every aspect of universe, and also it governs with the physical world and natural phenomena around us. Whereas AI, which is governed with computer science, making machines to learn, think like human beings. It is just a boom in all fields. One of my professors said we have to ask a question why for everything. So we have to ask the question why physics.
Your slide is not moving.
So now?
No. I'm seeing physics AI next slide. Next slide is not coming. Yeah, now. You are at page number 11, right? No, now I am seeing page number 6, slide number 6.
So now?
And now I don't see the page number, but why physics important in AI? That page is I'm seeing.
Okay, sir. Let me change the slide. Is it visible to you? I'm in page 10 now.
Page 10. I'm not seeing the page number. No, can you see? Can you read the title? What's the title?
Sir, it's about the physics is a fertile ground for AI applications.
No, I'm seeing why physics important in AI. That is the page which I'm seeing.
So give me 2 minutes.
10 மணி முடிக்கு அங்க உட்காந்துருந்தேன் எல்லாம் வெளியே வந்துட்டு போனேன்
Sir, now?
No.
Sir, okay, sir. I will present it from.
Tambi, you may come next one. Okay. Okay. What
Yes.
No,
Okay.
It looks the same.
Sir, now?
No, it looks the same as earlier.
Okay, sir. Give me 2 minutes. I will rectify it
I
and
think
I will
we will
present.
call you back. I will ask some on the next candidate to present. You come after that. Okay.
Okay, sir.
I'm going to சொல்லி அவங்க பேர் என்ன யார் பார்க்குறேன் அவங்க பேர்
Judge, please.
the next. நீங்க அடுத்தவங்களை கூப்பிட்டுருங்க இவர் அது கூட ரெடி ஆகும்.
Okay, sir.
Okay.
Lot number 23, Shanna from Virgo Wicklings. Lot number 23, Shanna from Virgo Wicklings.
Good afternoon, all present here. Am I audible?
Yes.
Thank you, sir.
Yeah.
Okay, now I'm going to dive into the topic as many people have given the introduction. And my name is Shiana and my team is Vigro Viklings. And let's see what is ML. So ML is a branch of artificial intelligence and it learns pattern from data and make decisions without being explicitly programmed because it learned from the experience. So let us understand what is explicitly programmed. Let's compare the traditional programming and now machine learning programs. In traditional programming, have to give a command or we have to write the whole program to give a specific result. But in machine learning program, you just have to give the order and it will produce the result. For here, the example, if the mail contains Agra, then the mail is marked as spam. And here in the machine learning program, we just have to give a command and it will resolve the mail. And how machine learning works. So first we have to prepare a training set data and we have to choose an algorithm and we have to train it and we have to evaluate if it is precise with the lifetime models and we have to do many models to improve and evaluate the model. So here in this flow chart we can see how the data is produced in machine learning. Here we have a huge set of data and we just took a sample from it and we will train it and we will evaluate it and we will give a specific algorithm to it and just again train it and we just evaluate the whole process. If it is approximate with the lifetime models, we will just keep it as a standard model. If we have find any other model which is more closer approximate to the lifetime model, we will choose the second one as the approximate model. So it will go on like this. We will just evaluate the model again and again to get a precise result. So need for ML in physics. Why we need ML in physics? Because we have to handle a large number of data. For example, for an astrophysics or any other field physics, we have to handle a large number of data and it requires a lot of time to process. So in traditional physics, it has only analytical solution simulation and it can be computationally expensive and it can't perform hidden patterns, or it can't optimize the solution. So we have to use ML in physics. How can we fuse computation with physics? First, we have to found a theory, and we have to do an experiment for it, and we have to stimulate the and we have to do simulation. For example, in lifetime example, many people in astrophysics create fake models of stars or pulsars to detect signals, and they will just do and they will just apply some algorithm, and they will take the result and they perform the same method for any other data they found in space. And for that very basic thing, we need to have a physical system, and we have to have a knowledge and data about it, and we have to produce a computational model, and then we have to produce a computational paradigm. Computational paradigm is an advancement of computational models, and then we will use some programming languages, and we will produce a computational tool. Then in what are the fields we use ML? So basically, many machine learning is used in the field of astrophysics and quantum physics. In astrophysics, we use for exoplanet detection, because as it is an ongoing research in astrophysics, exoplanet detection is very much a hot topic nowadays, because we have there are many kind of exoplanets like gaseous planet or many other things. And for galaxy classification, if it is spiral or any other specific shape it has, and for gravitational wave detection and cosmology, dark matter research. And how this let's see how it works. We have a training data, and it has hyperparameters. What hyperparameter means? It means the parameters of the machine learning, like how fast it processes or any other parameters it has, and we have to optimize it and have to produce an ML algorithm, and we keep it as a model. Then we will introduce a new data, and we will just evaluate using the training model, and we will produce a result. And in quantum mechanics and quantum computing, in quantum state classification, like if it is a separable or any other quantum state, we can classify using quantum machine learning. And IBM uses ML and also in quantum error correction. IBM uses ML to reduce error in quantum computing. IBM is an quantum software company which is producing many quantum computing states to develop softwares to produce an evaluation in the quantum computing and quantum machine learning. And we in quantum mechanics,
I
we
think
will just
the time is over, Shyama. You can go to the conclusion section. Yeah. You go to the conclusion page.
Okay, sir. So the need for why they gave Nobel Prize for this Boltzmann machine and Hopfield network is because they use neural patterns to produce algorithms, and which is very much needed for today because it can reduce a lot of noise reduction. Thank you, sir.
What is the difference between Boltzmann machine and the restricted Boltzmann machine?
In Boltzmann machine, the hidden and visible are interlinked, but in a restricted Boltzmann machine, there is no connection between the visible. There is no interlink between the visible neurons, sir.
What is visible neuron? What is invisible? What is visible neuron?
Actually, hidden neurons mean it has a direct connection with the input, and for visible, it can only it is one step away from the input, so it has to depend upon hidden variables to get information from the data, sir.
Oh, can you tell me one more time?
So hidden variable is the one that gets data from the machine.
Hidden variable.
As a hidden variable gets data from the source, and it will provide to the visible. Actually, hidden variable act as a transporter. The visible will provide us, and it will check whether the given data has matched with any of the source, and it will provide the result. So hidden variable has a direct connection with the input, and visible has to depend upon the hidden, because it was one step away from the hidden variables, sir.
Okay, whether backward propagation has been used in the restricted Boltzmann machine?
Yes, sir.
Do you know what is back propagation?
In backward propagation, the data will after the data is recognized from the source, it will just search for a stable state to rely on. So it just go backwards to the source again.
What is stable?
Stable, it has actually this neurons work based on energies. They will have just reduced the weight to produce a stable variable, sir. So the stable variable,
The energy means what? Can you compare what is the brain's energy and machine learning's energy?
in machine learning energy, it's, I have no idea about it, sir, but I will just
Okay, right. Okay, Shana. Okay, good.
thank you, sir.
Yeah, you can leave now. Good, thanks. You can leave, Shana. Yeah. You can.
Number 22, Alagamurugan from Thermal Thunder.
Yes, ma'am. Yes, ma'am.
You can present now.
Okay, ma'am. Am I audible to everyone?
Yes,
Screen visible? Sir, sorry for, I apologize for the inconvenience.
But still, some part is not visible. I think the left part is not visible now. Yeah, you
Yes, sir.
got it. Let's try to complete. Yeah, it's getting late.
Sir, is my screen visible?
No, screen is visible, yes, but not the slide. I mean, the particular page.
The transition?
No, no.
Is the transition?
No, I'm seeing your files. Not anything else. All your files are now displayed. Correct.
Sir, now?
Yes, perfect. Yeah. I mean, yeah. Still some part is missing, but you go ahead. It's getting late. Yeah.
Is the slides are changing, sir?
No.
Sir, now?
Yeah. 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 Now it's perfect. Now it's perfect.
Okay, sir.
Yeah. Yeah.
Sorry
Yeah.
for the
Yeah,
inconvenience
Go
caused.
ahead. Go ahead.
Okay, I'll start with that. Start with the topics that physics, which is concerned with the aspect of universe. It studies the physical world and the natural phenomena around us. While AI, it is a computer science field, making machines to learn, think like human. It's creating a boom in all fields. We have to ask a question: why physics is important in AI? Exactly, physics is a fertile ground for AI applications. It is a synergy of physics and AI. It helps to understand the laws of universe and how they govern the physical quantities. It also helps in solving problems, analyzing behavior, and analyzing the data. With intrinsic theories and impeccable complexities, it paves the way for new AI tools. We will start with the history. Machine learning fusing physics is not a recent phenomenon. It is pioneered in 1980. For example, spin glasses that used in statistical mechanics. It created a well potential of the machine learning. The first workshop on AI in high energy and nuclear physics is happened in 1990. Let me move on to the transforming researches through AI. In fact, AI plays a crucial role in particle physics. It analyzes rare particle interactions and potential, unveiling new aspects of particle physics. And also, it is used in cosmology. It analyzes the data from telescopes like James Webb and many other telescopes and modeling the galaxy formations from Big Bang theory also. Is the process. The topic is the process will be very suitable for AI. It reduces the extensive computations. It maintains accuracy. It creates new materials with desired properties also. Real-time applications. Quantum tomography is a best real-time applications of AI with physics. It reconstructs quantum states, developing quantum computing. It helps in discovering exotic properties. Also in astrophysics, it process and interprets vast astronomical data. Simulations with AI helps in know about the dark matters, supernovas, black holes, and even depth cosmic objects. Philosophical and ethical consideration. It would be very important in most of the fields of science. It discusses AI predictions not immediately understandable by human. It has to be processed and converted. Many may change the role of physicists in discovering new ideas. Reliability is a serious concern in AI. Challenges. Developing specific algorithm may be complex. Models must accommodate physical laws and constraints. Nonlinear dynamic data difficult to predict with standard techniques. Opportunities. It provides various vast opportunities for the researchers and scientists. Professional learning youngsters get skilled both in AI and computational AI techniques. It is our responsibility to also provide some knowledge to provide contribution to AI technology. Futuristic scope. In my point of view, AI in physics is a boom in the scientific era. It helps in analyzing data which far exceeds the human capabilities. It transforms more complex theories into AI tools. It needs crucial support between AI scientists and physicists. Let me go on to the topic of AI physicists. Jeffrey Hinton and John Hopfield, who pioneered advancement in image recognition using neural networks. They was awarded Nobel Prize in 2024 under physics. I have to mention another scientist. Hope you all know that Elon Musk, who introduced the brain computer, which is a neural chip, which also works similar to human brains. And thank you for listening. Thank you all.
Okay. So, can you go to this? You talked about quantum machine learning or something, right? There's exotic properties of quantum states. Okay. What is the slide number? Can you go back to that slide?
It's 22.
22. Okay. Yeah. Yeah. What do you mean by exotic property?
Sir, quantum computing generally refers to the concepts which are not covered with the classical computer. So that can also be that I have mentioned that exotic properties. It can
classical
also
computer, quantum computer. The difference between classical computer and quantum computer. And what is the difference between classical machine learning and quantum learning?
Sir, I don't know that much. I'll quit it.
Okay. Yeah. Okay. Thanks, Alak Murugan. Thank you.
Thank you. Thank you.
We extend our heartfelt appreciation to our Honorable Judge, Professor M. Sendil Valense, for your tireless efforts in dispensing justice and being a beacon of fairness. Thank you for your invaluable services for us. Once again, thank you for your cooperation and invaluable judgment. I appreciate all the participants for your active participation. Let's wait for the result. Now you can all leave the meeting.